We've removed the charger and the brackets that held the vacuum reservoir and vacuum pump, if you refer to earlier footage here. What I wanted to show you now is, as I'm disassembling this, all of a sudden I see a teachable moment, and so that's what this is. So I want to show you how this, zoom in here. Sorry for the shaky view. So what we have is the main disconnect here. And it comes from the main disconnect over here to the main contactor. Okay. So what I notice is that the lug is on top of these other little terminals. Or not terminals, but other little connectors. Let me pull the nut off here. And the power really, it's not going through the bolt. It's the mating surface of the lug. So by having these there, we're adding resistance. And since this is, a high power point, that's not the way you want to do it. You would want to have the lug down on this base first, and then anything else that you would put there, and I wouldn't put this many things on there personally, but you want to have the lug down so you have this good surface area, because that's what's the current flow is going to go mainly that surface, not through just the stud up here with the nut. So that's what I recommend. Put your lugs against any surface that you have here. We'll see what they see. This one is done correctly on the shunt over here. Of course, I have it zoomed in where you can't see that. Hang on, let me back out. I'm pointing to something you can't see. I'm sorry. So that side of the shunt is done correctly, but this one wasn't. Another thing is, notice the size of this ring terminal here. You want to have, the proper size for your stud. Okay? So here's another example of using the wrong size lug. Turn around my viewfinder so I can make sure I'm in the... So this lug is going with this stud. And you can see that the washer almost goes through the ID of the hole in this lug. So what that means is when we put this on here, we're not getting the same amount of surface contact that you would if you had the proper size hole in your lug. That's one size, and they've got another size here. Again, not the correct size. Let's see what's behind door number 3 here. Nope. Oh, you can see it's the wrong size. So luckily these cables seem long enough. So we'll put the correct lug on this, on all of these. There's several spots where I've come across this kind of thing. So those of you who are, there are a lot of these conversions that are being, sold that somebody else has done, and you buy it as a used, previously converted conversion. You really want to take a look at things. You couldn't tell that with the boots on there, and you may not even be able to tell it. But just some ideas of things you may want to inspect if you want to get proper performance out of your vehicle. You want to avoid having hot spots and having problems, because increased resistance means heat, and heat means trouble. So you would just be getting these terminals much hotter than they should get. So, and it also, improper size like this, it's more apt to come loose, and when it comes loose, again, resistance and heat. not your friend. I'm preparing the upper board here for removal, and so I'm going to leave the DC to DC converter connected, but I was checking wiring here. Well, this is the Anderson plug is your 12 volts out, and this wiring here, number 12 gauge wire here, is your high voltage in. Well, just looking to see where it connects to, and I noticed the black wire here. I'll pull on it and you can take a look. Okay, try this again. So there's a ground terminal down here, and the black wire that's supposed to be from the traction pack negative, you can see it right there. It goes to ground. So that DC to DC converter wasn't going to work. So I don't know where the positive is going to. And well, it's going to a relay here, but where it goes from there, and look at that. Here's another example. So look at what gauge wire we've got going into the DC to DC converter. Okay, it's coming out of the normally open contact on this relay, and here's the common, and look at the wire on the common. It's like a 14 gauge wire, and this is a 10 gauge wire. Not the way to do it, folks. Okay, your circuit needs to all be consistent, and it needs to match the load. I'll tell you right now, this little wire right here, I don't know if that's 14, might be 16 gauge. That feels like a 16 maybe. This is not, look at the size of the wire that's going in. That should be consistent throughout. Okay, so we'll change all of that. That's just not going to work. And where does this one go to? Okay, it goes down here to this, which is labeled. It went to the contactor. Yep. Okay, not very interesting video there. I'm sorry, I was trying to read my tag. So this is going to be a little bit of a mess. So I get this board out here, and then we'll clean up the 12 volt stuff and have it ready to wire here. Look at all the shaving stuff laying around. Keep your workspace clean and stuff. These little things could short against something. You don't know, or they could blow off into somewhere else. So we'll continue that. I'm going to take care of this DC to DC converter so that when we lift this plate out, we don't have anything hanging us up. So it's the end of the day. I'm going to get out of here. But when we continue tomorrow on this, we'll be doing the coolant system. This plug, the wiring harness here is ready to disconnect. I'll disconnect that. But the cooling system will be the last thing to be disconnected here, and it looks like the low point in the system will be the radiator. So we'll disconnect from the radiator and see what drains down. And then, of course, we're going to have to disconnect from the chill plate here. And it's interesting, again, you get different size hoses. Nope. Power steering reservoir is empty. So we wouldn't want to give power to that. So we'll have to take a look and see what's going on with there. But I mean, you know, I've pushed some wires off the back here that were laying on top here. Just pushed them out of the way because I'm going to sort through everything. But a lot of this down here was just that way to begin with. And I mean, that's how you have problems. You need to, you know, like this stuff where it's run through the loom and everything. That's nice. Not going to have any worries. The problem I've noticed throughout this vehicle is they use these double, these adhesive pads, and they just don't hold up very well, especially in an automotive environment where you have heat and vibration, and obviously it's not sticking to this new paint very well because they've come loose in almost every location. So I might replace it with some stuff that I have just for, instead of having to redo everything totally. I've got some industrial grade adhesive stuff that we use in the engraving business. But we'll continue on, continue to observe. This is good to know that's empty. So we want to make sure we don't have power coming out. Normally the power steering would come on with the ignition. So we want to make sure that we don't turn on the ignition until we make sure that that's not going to come on. Don't want to run it dry. So we're making headway. And so we want to get this big aluminum plate out of here so that we can inspect the cells below and also provide a method for holding those cells in place. There's nothing to prevent them from bouncing upward. They're contained on the perimeter but not on the upward movement. So not a good idea to have uncontained cells with a nice big conductive plate on top. So we're going to have to put a piece between there to make sure that we don't accidentally short things out when we're removing this plate. Well, this is the component board with all the components removed. And so the throttle hooked onto it, the coolant reservoir was connected to it, the vacuum pump and vacuum reservoir were connected to it, and then mounted on it were the controller, the DC-DC converter, the charger, the shunt, the KSI relay, your main disconnect, the main contactor, and the heater contactor. Those were all items that were on this board. So we removed them, one, because I didn't like the way a lot of them were attached, very, with some self-tappers and a few other things, just not something that's going to hold up in this automotive environment. And the other reason is that we want to be able to inspect these cells. And you can see the cells are just below this metal plate. It's an aluminum plate, 1/4 inch thick. So we need to put something between the top of the cells and this plate. Now to get this plate out, we can't just raise it up because it's underneath this lip here. It's going to hit, we can't really go back because of the vacuum booster there. We can't really go up unless we remove the vacuum fitting, and we could do that. But what I think I'm going to do instead, because we're going to remount this board, or we're going to mount this board, not remount it, we're going to mount it differently. We're going to get rid of the all thread, and because it just, even with no weight on it, it wobbles around. And you can hear it clunking against the... So with the weight on there, you're trying to think, it's just not the way that I feel comfortable. And, you know, people do things different ways, but we're trying to make this something that's going to be able to stand the test of time. The driver of this vehicle is a young woman, and she's not going to want to have to deal with anything. So we want to make this as clean, simple, and reliable as possible. So we're going to mount it in a different fashion. Like I said, I'm going to try to come up with a way to hinge this, but I've had some ideas, but we'll wait till we get those cells out of the way to start developing that idea a little more. But back to removing the plate. So what I think I'm going to do is we'll remove these upper nuts, and then we're going to, of course, you know, like I said, put something to insulate between the plate and the cells. Remove the top nut, and then loosen up the bottom nut sufficiently to allow this piece of all thread to drop below the height of the plate and just lift the plate out. Hopefully we'll be able to move forward a little bit to clear the vacuum hose, and then tilt the back end up and bring it out. That's the plan. We'll see. So next up, gotta put something between these cells. Don't want to take any chance on this, you know, accidentally connecting. Matter of fact, I'm going to measure. I'm kind of curious what kind of clearance we have. So when we put this plate back, it was clear in the hood before, so we know that we can have clearance if we go back to this height again. So let me measure that. So it looks like the clearance between the top of the bolt heads on those interconnects to the bottom of that aluminum plate is 3/4 of an inch. So that's what we have to deal with. And so let me find something to put between that to not have a short, and we'll see if we can pull this plate out of here. Well, here's a piece of foam or styrofoam that comes in the battery boxes when they're shipped. Sometimes it pays not to throw everything away. So now I gotta trim it a little bit so that it will fit underneath this plate, but you can see it's about the right thickness, and overall it's a little bit bigger than the plate, so this will work. All I have to do is get it in there. Here's a shot with the foam in there. So it's covering all of the terminals. It actually extends beyond the cells all the way around. So now let's loosen up these pieces of all thread and get them out of the way. So you can see what I did. Foam on top of the cells. Remove the top nut on the plate. Loosen this bottom one. Brought that nut up far enough to drop that below the plate. Did that all four corners and just lifted the plate out. So now let's take a look. I'm going to mount the camera on the tripod. We'll take a look at what it looks like underneath. Let's take a look at these tops of these cells here. Well, a little dirty. Okay, so now what I'm going to do is I'll disconnect the two cables going out, front corner and this rear corner. We'll remove those, and then we'll start removing the interconnects. And once the interconnect's removed, we'll take voltage reading on these cells, and hopefully these are all okay. we had 2 bad ones out of the 22 in the rear. And I hope we have no bad ones out of the front here, but we'll find out shortly.